So this is a transportation problem that is given to us. There are 3 plants A, B, C. There are 4 warehouses P, Q, R, S. The supply is given at each plant, demand is given at each warehouse, and this is the cost matrix. This is the transportation cost per unit is given from each plant to each warehouse. And we are asked to find initial feasible solution by 3 methods, that is NWCR, LCM and RAM. Okay, so this is the level 1 solution. Initial feasible solution is the level 1 solution of a transportation problem. So in this video we will see how to find solutions by each of the methods. Okay, so now we are going to find the IFS first by NWCR, that is the northwest corner rule. Now this is the transportation table in which there is a supply side and this is the demand side. There are 3 supply centers, 3 plants ABC. Supply value we have written in the table. There are 4 warehouses PQRS. We have written the demand in the table. And this is the matrix, the cost matrix. This cost matrix that was given in the question, we have represented the data in each respective cell or box. Each box is called a cell. So for example, from A to P, cost is 38. So we write 38 in the corner of that cell. And when we find the solution, whatever allocation we get, that is how many units we get, that answer we will be writing at the center of the cell. Okay. So now we are going to start the solution. Okay, now before actually you start the solution, you should check whether this problem is a balanced problem or unbalanced problem. How to find that? You add the total supply, you will get this as 35 units. Then add the total demand, that is also 35 units. So total supply is equal to total demand. So therefore you can say that the problem is balanced. If the total supply is not equal to total demand, then accordingly you have to take either a dummy row or a dummy column for balancing the question. Okay, but now in this case the problem is balanced, so we don't need a dummy. Okay, now we will start with the IFS by NWCR. Northwest corner rule. So it is like this. This is north and this is west. So this is northwest. Means the left side corner. So the principle of this method is that you should start giving the allocations from the left side corner. Now in this table, the first left side corner is here, that is AP. Okay, now see here, at A the supply is 7 units. Okay, and at P the demand is 5 units. So the allocation that we give is always the lower number out of this. So 7 and 5, so lower number is 5. So we can give only 5 units. So we will write here 5. Okay, this is called allocation. Okay, so it means from A to P we have given allocation of 5 units. Okay, I repeat, the first left side corner was AP. At A supply was 7, at P demand is 5. So 5 and 7, lower number was 5. So we have given allocation of 5. After this, now out of 7, now only 2 units will remain balanced. And 5 out of 5 is given, so this will become 0. It means column P is over. So now here there can be no more allocation. So we are cancelling it. Then next, now P is over. Now the next corner in the table is AQ here. Now supply is 2 units and demand is 8 units. So 2 and 8, so we can give here 2 units. Okay, the lower number. And now 2 minus 2, we have given all 2 units, so this becomes 0. So now this row is over. And 8 out of 8 we have given 2 units, so 8 minus 2, the balance quantity here will remain 6. Now the remaining table is this much. So the next corner here is BQ. So at B supply is 10 and at Q demand is 6. So 6 and 10 we can give 6 units. Okay. Now the remaining supply at B, 10 minus 6, remaining supply will be 4 units. And Q, 6 minus 6, it is 0. So now Q is over. So this column is now over. Okay. Next, now this much is remaining. The next corner is now BR here. Supply is 4 units and demand is 7 units. 4, 7. So you can give 4 units. Okay. So we have given 4 units here. And 4 minus 4, now at B supply becomes 0. So now this B is over. And 7 minus 4. The balance units now remain 3. Okay. Now A is over, B is over, only C is remaining. So whatever quantity is remaining here, that will go directly in C only. So these 3 units will come here, and these 15 units, that's 3 units will come in CR, and these 15 units here will come in CS. So 3 will come here, 15 will come here, and now if you check this 3 minus 3, you are given 3, so this is 0. 15 out of 15 you are given, so this is now 0, and 3 plus 15 is 18. So now out of 18, all 18 you are given. Now there is no balance on supply side or demand side, and now the solution is complete. So this is how we give allocation for NWCR. And after doing this, there is one check we have to perform, that is called check for non-degeneracy. Its principle is you should check how many allocations you have. We will see how many allocations we have. Number of allocations. How many allocations we have? See, 1, 2, 3, 4, 5 and 6. So we have 6 allocations. We will check this with m plus n minus 1. M means how many rows, n means how many columns. So how many rows? A, B, C. So 3 rows. And how many? N means columns. So 4 columns. So 3 plus 4 minus 1 is 6. So this is 6. This is also 6. They should always be equal. Then it means that the solution is okay. It means there is no degeneracy. Degeneracy means some kind of abnormality. Okay. So it means now the solution is okay. So we say okay, therefore okay. So you can say no degeneracy. And then we calculate the cost. Cost we can calculate by multiplying number of units with unit cost. Say for example at AP we have given 5 units, unit cost is 38. So we multiply it, that is 5 into 38 plus 2 into 60 plus 6 into 60 plus 4 into 80 plus 3 into 120 plus 15 into 40. Okay, so this is how we calculate cost. We multiply quantity with unit cost, and when you add all this, you will get total cost as rupees 1950. Okay, so now this our IFS by NWCR is over. Okay, so now we will see the second method, that is the least cost method. Okay, so we will now find IFS by LCM, that is the least cost method. The principle of least cost method is that you should take the entire table and start allocation from that cell where the cost is lowest or minimum. So now if you compare all the values, we will see that the lowest cost is, here it is 24, here it is 60, here it is 20. So the lowest cost is 20, that is in CQ. So we will start allocation from CQ. Now here supply is 18 and demand is 8, so we will give 8 units. So now when we give 8 units here, the balance at C, out of 18 we have given 8, so the balance here will be 10, and at Q, out of 8 we have given all, so it is 0, so now Q will cancel. Okay, so now there will be no entry in Q. Now we should not consider these costs for further calculation. Now check the remaining table. Now the next minimum cost is 24, that is AS. So we will give allocation in AS. Here supply is 7 and here demand is 15. So 7 and 15, lower number is 7. So we will give here 7 units. So now out of 7 we have given all 7. So 7 minus 7 is 0, and this row is now cancelled. 15 minus 7 here, now the balance quantity will be 8. Okay, now the next 140, 80, 120. So the remaining next minimum is 40. This 38 we cannot take because it is cancelled. So the next minimum cost is 40. Supply 10 units and demand is 8. So 8, 10. So lower value is 8. So this 8 out of 8, 0, and this column will cancel. And for 10, balance units will be 2. Now 140, 80 and 80, 120. So now the minimum cost is 80 and there are 2 80s. So how to decide which 80 to give? So the thumb rule is you should give that cost, you should give allocation in that cell where you can give a higher value. Here in this 80, 7 and 10, so you can give 7 units. in this 80, 2 and 5 you can give 2 units. So it is better that you start with higher value 7. So we will give this 80. 10 and 7, so we will give 7 units. 7 minus 7, 0. So this column will cancel. And 10 minus 7, 3. And now Q, R and S, all three columns are over. Only one column is remaining. So whatever is here, you can give directly. So this 3 you will write here, and this 2 you will write here. Okay. And now you cross check. 3 out of 3 is given. This is 0. 2 out of 2 is given. So this 2 is 0. 3 plus 2 is 5. So all demand now becomes 0. So now there is no outstanding supply or outstanding demand. Now again, we will just have a check for non-degeneracy. Check for non-degeneracy you should perform after every solution. Number of allocations. One, 2, 3, 4, 5, 6. We have 6 allocations. N plus n minus 1. N is number of rows, 3 rows. N is number of columns, 4 columns. Minus 1, 6. So therefore, okay. Number of allocations are 6. N plus n minus 1 is 6. They are equal, so it is okay. And then we will do the cost calculation, that is the IFS cost by LCM method. Okay. So now multiply each allocation by its unit cost. 7 into 24 plus 3 into 140 plus 7 into 80 plus 2 into 80 plus 8 into 20 plus 8 into 40. And when you add this, you will get total cost as 1788. Okay, so this is how we solve the IFS by least cost method. Okay, so now the third method, that is the Vogel's approximation method or VAM. Now this is also called a method of penalties. So this is our normal transportation table, supply, demand and the unit costs. So what is extra in this is we are making provisions horizontally for row wise and vertically for column wise. We are making provisions for penalties. Now what is the penalty? You can write down the formula of penalty. Penalty is equal to difference between two minimum costs or two lowest costs for either row or column. So when we calculate the penalty, what we do is we calculate the difference between the two minimum costs. So if we are calculating row penalty, we will take the difference row wise. If we are calculating column penalty, we will take the difference column wise. Now first we will calculate all P1. P1 means first penalties. Now we start from A. The lowest cost is 24 and next lowest is 38. So 38 and 24. So the difference is 14. So this penalty will be 14. Then B, lowest is 60 and the next lowest is 80. So 60 and 80, two minimum costs and difference is 20. So this penalty is 20. Then C, lowest is 20 and next is 40. So 20 and 40, the difference is 20. So again penalty here is 20. So this is P1 for all the rows. Same way now calculate P1 of all columns. First column, lowest is 38 and next is 80. So 80 and 38, difference is 42. Next Q, lowest is 20 and next is 60. Any 60 you can say. So 20 and 60, so the difference is 40. R, minimum is 80 and next is 100. So 80 and 100, penalty is 20. Then S, minimum is 24 and next is 40. So 40, 24, difference is 60. Okay, so now we have calculated all P1. Now the allocation will be given on the basis of penalties, and the rule of allocation is like this. Start with highest penalty and and find corresponding minimum cost. So two things you have to remember. First thing, how to calculate penalty, and second thing, what is the rule of allocation. So I repeat, penalty is the difference between two minimum costs for each row and each column. And the rule of allocation is you consider all the penalties, row as well as column, and select the highest penalty and give allocation in corresponding minimum cost. Now compare all the penalties 14, 20, 20, 42, 40, 20, 16. So the highest penalty is 42. So we will start with 42 in this column. Now in this column, three costs are there, out of which minimum is 38. That is AP. So allocation will go in AP. Supply 7, demand 5, 5 and 7, lower number is 5. So we will give here 5 units. Okay. Now 5 units we have given. Out of 7 we have given 5. So now balance is 2. For P, 5 out of 5 is given, so balance 0, column will cancel. Now this column is cancelled, so now there will be no penalty for this column. Now we can go to the next penalties. Now we will not consider these costs. Now we will go in P2 and follow the same method, point number 1. Difference between two lowest costs. Now minimum cost is 24 and next is 60. So 60, 24, so difference is 36. So now our penalty is 36. In B, minimum is 60, next is 80. So 60, 80, difference is 20. C, minimum 20, next is 40. So 20, 40, so difference is 20. Now vertically, 20 minimum and 60, 20, 60, so penalty is now 40. Here, 80 and 100, difference is 20, so penalty is 20. And last, minimum 24, next is 40, so 40 minus 24 is 60. So now these are our second round of penalties, and now again we will follow the same rule. 36, 20, 20, 40, 20, 16. So now highest penalty is now 40, so now we start with 40. Now in this column, minimum cost is 20, supply is 18, demand is 8. So we will give 8 units, 8 and 18, lower number is 8. Now 18, 18 minus 8, balance is 10, 8 minus 8, 0, column will cancel. And now no penalties here. Now same rule for third penalty is P3, 124, so difference is 76, 80, 120, so difference is 40, 120, 40, difference is 80. Vertically for R, 80, 100, so penalty is 20, S, 24, 40, penalty is 16. Now 76, 80, 20, 16, so highest is 80. So now we go in 80. Okay, horizontally. Two costs 120 and 40. So lowest is 40. So we will give allocation in 40. Supply 10, demand is 15. So we can give 10 units. Okay, so now 10 minus 10, this becomes 0. 15 minus 10, balance is 5. So this is 0. So now this row is open. So no penalty here. Now we go in P4, 124, so 76, 80, 120, so 40, 180, so 20, and 24 and 120, so the difference is 96. So the penalty here is 96. Now you compare, the highest penalty is 96, so you give in 96. Now in this column, lowest cost is 24. Supply 2 and demand is 5, so we can give 2 units. So 2 units given, so 2 minus 2 is 0. Now this row is over, no penalty here. And here 5 minus 2, balance will be 3. Okay. Now if you see, only one row is remaining. So whatever remains here will automatically go here. We don't need any penalty calculation now. So this 7 will come here. This 3 units will come here. And if you see, 7 plus 3 is 10, so balance is 0. 7 minus 7, balance is 0. 3 minus 3, balance is 0. And all supply demand balances are now over. Okay, so now our solution is complete. So that is why initially we have made provision up to P5, because any problem generally gets solved within either 4 or 5 penalties. So now our IFS is complete. Now as normally we will do check for non-degeneracy. Number of allocations. One, two, three, four, five, six allocations. M plus n minus 1. M means number of rows, n means number of columns. 3 plus 4 minus 1 is 6, so therefore okay. So there is no degeneracy. Then we calculate the IFS cost using the VAM method. So this is the cost of VAM. So that is now 5 into 38 plus 2 into 24 plus 7 into 18 plus 3 into 120. Okay, 3 into 120, then 8 into 20 plus 10 into 40. And when you add this, you will get total cost as rupees 1718. Now if you compare the costs of all the three methods, that is NWCR, LCM and VAM, you will find that VAM always gives the lowest or minimum cost. That is why for finding the initial feasible solution, VAM is the most preferred method because it always gives us the most lowest or minimum cost. Okay.